Good morning, my dear students. So come to today's class. So today I will start your exercise 3.7. So before starting 3.7, so let us finish the question number 3 of exercise 3.6. Okay. So very easy one. Identify which of the following is prime factorization. Okay. So the first one, 3a. It is given that 324 is equal 2 into 2 into 3 into 3, 2 into 2 into 3 into 3 into 4. Okay. So look at this one. In this case 4 is present, and all of you know that 4 is not a prime number. Okay. 4 is a composite number. That means 324 is not a prime factorization. So directly write which is not a prime factorization. Prime factorizations. Okay. So question number B, 63, which is 3 into 3 into 7. Okay, so all these are prime numbers, so which is prime factorization. Okay. So question number C. Question number C is what? 96. 4 is present, so obviously it is not a prime factorization. C is what? 96. 4 into 2 into 2 into 2 into 3. Okay, which is not prime factorization because again 4 is present here, which is not prime factorization. Okay, so question number D. D is what? 54. 2 into 3 into 9. It is 54. 2 into 3 into 9. And look at this one. 9 is not a prime number. That is a composite number. That is why again which is not prime factorization. Not prime factorization. Okay. So look at the last one, 74. 2 into 37. And 37 is also a prime number, 2 is also a prime number. That means it will be a prime factorization. Okay. So question number E. 74 is equal to 2 into 37. 37 is also prime number, 2 is also a prime number. So that means it is a prime factorization, which is prime factorization. Okay. So your exercise 3.6 completed here. So now come to the 3.7. That is highest common factor. That means HCF. So it is very important topic, HCF, highest common factor. Okay. So highest common factor HCF you can find in several ways. So first thing you have to use the prime factorization method. So easy one. So second one is you have to divide by Euclid algorithm. That means by division method. Okay. So at first let us discuss about the prime factorization method. So let us discuss about the example number 1. So look at your page number 47. Find HCF of 150 and 210 by prime factorization method. So let us at first discuss one example here. Example 1. Okay. So we have to find HCF of 150 and 210 by prime factorization method. If we discuss the example here, then it becomes very easy to solve the questions of the exercise. Okay. So always do the examples in your home. So the first one is find HCF of 150 and 210 by prime. So given numbers are Suppose you write given first line is given numbers are 150 and 210. Okay, so these two numbers are given to us, and they are asking that we have to apply the prime factorization method, and then we have to find the HCF. So at first we just write the given numbers are 150 and 210. So now by prime factorization method, we have to write this sentence. Okay, method we get, that means we apply here prime factorization method. We get, so you just apply the prime factorization. And what is prime factorization? I think all of you solve this type of question, prime factorization method, from class 4. Okay, that means you have to divide the given number by prime numbers. So at first 150, you just divide by smallest prime number 2, because this number is even number. The last digit is 0, that means this number is even, so that means this is divisible by 2, so you divide by 2. So 2 7s are 14, 1 carry on 10, so 250, that means 75. Okay, so now look at this one, 7 plus 5, the sum of the digits is 12, and 12 is divisible by 3, that means you can divide this number by 3, so 3, it becomes 25. So last digit is 5, so you can divide by 5, so 5. That means 150 becomes like this. Okay, again you suppose divide 210. Okay, so again last digit, so 2 10 105, 5 plus 1 6, you can divide by 3, 3 3s are 9, 1 is 15, 3 5s are 15. Okay, again you can divide by 5, 7, 200, so 105, 3 3s are 9, 1 15, 3 15, and 5 7, so all are the prime numbers. Okay, after doing this you just write, therefore 150, the prime factorization of 150 is what? 2 into 3 into 5 into 5, and prime factorization of 210 is what? 2 into 3 into 5 into 7. Okay, so now the HCF is the common factors of these two. Okay, so therefore HCF of multiplication of common factors of this, HCF of 150 and 210 is equal to, just look at the common factors here. At first you find the common factor, that means both the numbers must be belongs to 150 and must be below to 200. So then look at these two. 2 is present in the factors of 150 as well as in 210. Now look at this one again, 3 3. Look at this one, 5 5. 7 is not actually in 150. That means you have to omit 7. Okay. So now look at this one. Which number is common? 2. You just write into 3 into 5. That means the multiplication of the common factors is your HCF. So 2 3s are 6, 6 5s are 30. That means 30 is your highest common factor of the two given numbers. Okay. So similarly you can solve the example number 2 also. Example number 2 you solve in your home. Okay. In this case 3 numbers are given, 72, 64 and 48. Same method you just apply, and you can find the HCF. Okay, so this is example number 2. All of you solve in your home. Okay, and in my next video I will solve the questions of exercise 3.7, question number 1. Okay.